So now before moving to the next part of matrix, let us understand another very useful concept called transpose of a matrix. So in many mathematical and physical problems, we will need to rearrange the elements of a matrix in different ways without changing its actual value. These rearrangements simplify calculations and also is important in topics like vector transformation, linear algebra, quantum mechanics, electrodynamics. So transpose of a matrix is obtained basically by interchanging rows into columns and columns into rows. So in simple terms, the first row becomes the first column and the first column becomes the first row. So this operation gives a new matrix which is closely related to the original one. Understanding transpose of a matrix will also help us study special matrices and various matrix properties in later topics. So let us start off with this topic. For example, if A is a matrix which is A, B, C and D, then A transpose, which is represented as A with a T in the superscript, is equal to AB and CD. So basically, as you can see, the first row changes to first column and the second row changes to second column. So this is transpose, changing rows into column and vice versa. Now let us look into some of the properties of transpose. So what are the properties of transpose? A transpose and transpose of that will give us A. A inverse transpose will give us, A transpose inverse. Alright, now A plus B transpose will give us A transpose plus B transpose. Now AB transpose will give us B transpose into A transpose. Alright. So transpose of conjugate basically is equal to conjugate of transpose. What is a conjugate? Conjugate is nothing but in a matrix, if we replace iota by minus iota, it becomes its complex conjugate. Alright. So a dagger, this symbol is called dagger. A plus which looks like a dagger is called a dagger. So what is a dagger? What does this dagger symbol do to A? What it does is it finds its complex conjugates transpose. Alright, which is again equal to A transpose and its complex conjugate. So let us clarify these symbols. The star basically gives the conjugate, alright. T basically stands for transpose, alright. This plus sign stands for dagger, alright. Now let us look into our example. Alright, So consider a matrix A, which is iota, 3 iota, 2 iota, and minus iota. Alright. So what will A dagger be? A dagger is what? A conjugate transpose, right? So what does conjugate do to this matrix? It changes all the iota to minus iota, right? So it will change to minus iota, minus 3 iota, minus 2 iota, and plus iota. Why? Because there was already a minus sign to this iota from before. And we need to find transpose of this, right? So this is what A dagger does. Transpose of its conjugate. Now what will this transpose do? Transpose will change rows into columns and columns into rows. So minus iota, minus 3i, minus 2i and I. Alright. Now let us look into the properties of this dagger. So A dagger is equals to A complex conjugate transpose is equals to A transpose complex conjugate. Now next property says A dagger is equals to A. The third property says A inverse dagger is equals to A dagger inverse. Alright. Now the next property says A plus B dagger is equals to A dagger plus B dagger. The next property says AB dagger is equals to B dagger into A dagger. Alright. Now let us see an example where we need to find adjoint of A. So how do we find adjoint of A? Adjoint of A of a matrix. A here represents a matrix. Alright. Adjoint of a matrix. Matrix being called A. So adjoint of matrix is equals to nothing but transpose of its cofactors. Now what is a cofactor? We know what is a transpose, changing rows into columns and columns into rows, right? What is a cofactor? Cofactor is minus 1 to the power number of rows and its column into minor. We'll look into an example where R is to which row it belongs and column is to which column it belongs. Alright. Now let us look into an example so that this becomes easy to understand. Consider a matrix A is equal to 1, 2, 3, 4. Alright. Now, then let us not take this matrix up. Let us Let us change this element to 2. Alright, and let us change this element to 5. Okay, so let us consider a matrix 1, 2, 2, 5. Now determinant of A will be, we all know, 5 into 1 minus 2 into 2. So determinant of A will be 1. So now what will be adjoint of A? Our aim for this example, taking up this example, is to find adjoint of A, right? So what we have seen, that adjoint of A is transpose of cofactors. And what is cofactor? Cofactor is minor into minus 1 to the power number of row, minus 1 to the power row and column to which the element belongs. Alright. So now what we do is adjoint of A is minus 1 to the power, the first element will belong to first row and first column, so 1 plus 1, into what will be its minor. So in order to find the minor of one element, what we do is hide these 3 elements. What is left is 5, so our minor will be 5. Alright, so then for the next element it would be minus 1 to the power 1 plus 2, because although it belongs to row 1, but here the column changes to 2, right? It belongs to the first row and the second column. And for finding the second minor, what we do is hide the second term. So we are left with 2. So we'll write 2 here. Alright. Similarly, for the third term, it will be minus 1 to the power. Now here the column changes to second column, right? But it belongs to row 1. Sorry, I just said the opposite. So here the row changes to second row for the third element. The row changes to second row, but the column is the first column, right? So basically these are columns, vertical ones, and horizontal ones are rows. Alright. So it will be minus 1 to the power second 2 plus 1, because it belongs to the second row but first column. And again, if we apply a similar thing here, right? So hiding the third element would give us 2. Similarly, the fourth element belongs to second row and second column, so it will be minus 1 to the power 2 plus 2, and again hiding the fourth element would give us 1, so this would be 1. Alright, so our adjoint and transpose of this, right? So we need to find the cofactor and transpose of the cofactor, and the cofactor consists of minus 1 to the power row and column to which the element belongs multiplied by minor. Alright, so now this will give us minus 1 to the power 1 plus 1 is plus 1 plus 5 minus 1 to the power 1 plus 2 is minus, so minus 2, minus 1 to the power 2 plus 1 is minus 1, so minus 2, and minus 1 to the power 2 plus 2 is plus, so plus 1, and we need to find the transpose of this. So what will be our adjoint? Adjoint will turn out to be 5 minus 2 minus 2 1. Alright, so this is our adjoint of E. Alright, now let us look at some of the properties of adjoint of A. Alright, property number 1 says that A into adjoint of A is equals to adjoint of A into A is equals to determinant of A into I. Alright, so if determinant, now another property says that if determinant of a square matrix A of order n is mod of A, then, so if determinant of a square matrix A of order n is mod of A, then mod of A to the power n minus 1 will be equal to modulus of adjoint of A, that is determinant of adjoint of A. Alright, so if determinant of a square matrix A of order n is modulus of A, then modulus of adjoint of A turns out to be determinant of A to the power n minus 1, where n is the order of the matrix. Alright, so let us stop here today. In the next video, we'll look into some other properties of matrix and might solve some problems on matrix.